our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your CBNST class, that has been the class is your computer based numerical and statistical technique. That has been the classes 30. We had done your 99 classes in the last sessions. Wherein that we had completed your unit 1. In unit 1, that has been the computer arithmetic errors and rules of equation that we had done here, and in that we had done secant method, bisection method, Newton-Raphson method, regular Falsey method, and many more we had done here. But in terms of talking about unit 2, which has been the interpolations and curve fitting, that has been the unit 2 which we had started in the last classes, and we had done many of the questions related to the proof, and now we'll be continuing that as well. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So we go ahead for the same. The question is, prove the relationship. First, E equals to e to power hd, and second we prove for u equals to cos hd upon 2. So by the definition of shift operator, we know that EFX equals to fx plus h. Expanding fx plus h by the Taylor series around x will get EFX equals to fx plus h equals to fx plus h f dash x plus h square upon 2 f double dash x plus h cube upon 3, which is f triple dash x plus further. Then that has been equals to fx plus hd fx plus h square upon 2 d square fx plus h cube upon 3 d cube fx plus further it will be 1 plus hd plus h square d square upon 2 plus h cube d cube upon 3 plus fx equals to e to power hd, which is of fx. Now comparing the operator of fx on the both side, we'll get e equals to e to power hd, and on the same cases from this equation we get here mu value, and that is the mu value we have 1 upon 2 e power 1 by 2 plus e power minus 1 by 2. We'll open it out, half e power hd whole half plus e power h by d whole 1 minus 2, which is equals to e hd by 2 plus e minus hd by 2 whole upon 2, which is equals to cos hd upon 2, where we can say that e theta plus e minus theta upon 2 equals to cos h theta, where equals to cos h hd upon 2. Now we go ahead for the next question. We'll talk about it, which is being show that square equals to forward backward equals to backward forward. So for the same, we go ahead here. in the equation this it has been proved that equals to e 1 by 2 backward equals to e minus 1 by 2 forward. So that is being equals to e square, which is e 1 by 2 backward and equals to e minus 1 by 2 forward. Multiplying the above two equations, we'll get here square equals to e 1 by 2 backward into e minus 1 by 2 forward. So further it will be here equals to forward into backward. Now since product is associative, we can write the equation square equals to e1 by 2 forward into e minus 1 by 2 backward, which is being equals to forward into backward, and further it is equals to backward into forward, which is equals to forward into backward, that we get here. So that for the same that the above relation shows the product of the forward and the backward differences operator is associative. Now we go ahead for the next question. That what we'll have to discuss here is the question is to determine forward fx for fx equals to x cube minus 2x plus 5 with h equals to 1. So for the same we know that forward fx equals to fx plus h minus fx, so it will be fx plus h equals to x plus h का cube minus 2x plus h plus 5 equals to x cube plus 3x square h plus 3h square x plus h cube minus 2x minus 2h plus 5. Putting h equals to 1 in this equation, we get fx plus h equals to x cube plus 3x square plus 3x plus 1 minus 2x minus 2 plus 5 equals to x cube plus 3x square plus x plus 4. Putting fx x plus h and fx in this equation, so we get here the fx equals to x cube plus 3x square plus x, then plus 4 it minus x cube minus 2x plus 5 delta fx equals to 3x square plus 3x minus 1, that we go ahead further. Now we'll go ahead to find it out for the same, and that is being the another question here, which is also the important one, and that is being show that we go ahead for the next question, that is to be show that mu equals to 2 plus forward upon 2 under root 1 plus forward equals to 2 minus backward upon 2 on under root 1 minus backward here. So for this we go ahead here, and that what we'll have to talk about it, which is being from this equation we go ahead and that we find it out equals to 1 by 2 e 1 by 2 plus e minus 1 by 2 equals to 1 by 2 e1 by 2 plus 1 upon e1 by 2 equals to 1 by 2 e plus 1 upon e1 by 2. From the equation here that we have e equals to 1 plus forward, and hence that become equation equals to mu equals to 1 by 2, 1 plus forward plus 1 upon 1 plus forward upon 1 by 2 equals to 2 plus forward upon 2 under root 1 plus forward here, that we get. Now further we go ahead, and that what we'll talk about it, which is for considering this equation. So here for the same we go ahead. So for the same here it will be mu equals to 1 by 2 e 1 by 2 plus e minus 1 by 2 equals to 1 by 2, 1 upon e minus 1 by 2 plus e minus 1 by 2, which is equals to 1 by 2, 1 plus minus e minus 1 by 2 equals to 1 upon 2, 1 plus e minus 1 upon under root e minus 1 here. So from this equation, hence e inverse equals to 1 minus backward, and hence above the equation we get, so it will be on mu equals to 1 by 2, 1 plus 1 minus backward upon under root 1 minus backward equals to 2 minus backward upon 2 under root 1 minus backward, that we talk about it. So for the same, and that what we'll have to discuss as well, the both the relations are proved. Now we go ahead further, which has been the another one. The question is, show that the first is e equals to 1 plus forward. So e equals to 1 plus forward is proved, that we had proved it above. Okay, the second is forward equals to backward, 1 minus backward inverse. So for that we'll prove it from the right hand side, which is being backward 1 minus backward inverse. From this equation we know that backward operator equals to 1 minus e inverse, and 1 minus backward equals to e inverse. So for the same, that will put the value backward 1 minus backward inverse equals to 1 minus e inverse, and e inverse minus 1 equals to 1 minus e inverse e. So that will be equals to e minus 1 equals to forward. Okay, so you have the third one we'll have here is, that is being 1 plus forward equals to e minus 1 backward inverse. And consider this, that from the right hand side it will be e minus 1 backward inverse. From this equation we know that backward equals to 1 minus e inverse. So hence above equation will be e minus 1 backward inverse equals to e minus 1, 1 minus e inverse whole minus inverse equals to e minus 1, 1 upon 1 minus e inverse, that is being equals to e minus 1 e upon e minus 1 equals to e equals to 1 plus forward. Now we go ahead for the next, we'll talk about it, that is being the linear regression of fitting of a straight line. Linear regression fitting of a straight line. For a linear regression fitting of a straight line, in that when the data is given, sometimes it is necessary to approximate or fit the curve it with the help of the sum law. When the law is established such that squares of errors between the actual and approximated law is minimized, and it is called the least square approximation. So linear regression of fitting of a straight line, that the equation of a straight line that you know very well is y equals to a plus bx. In that we'll be having a formula sigma, sum of n I equals to 1 yi equals to n a plus b, sigma sum of n I equals to 1 xi. This is the first one, and sum of n I equals to 1 xi yi equals to a n I equals to 1 xi plus b n I equals to 1 xi square that we have. So the above two equations are solved for a and b. Okay, these equations will be solved for a and b. The question we get here, and that is being the important one of course, and which will be having to solve it out, and which is being the important one of course, and let's find it out for the same. The question is, in some determinations of value V of a carbon dioxide that is being dissolved in a given volume of water at a different temperature, and the following pairs of values were obtained. This is being asked in the question that we have a table. You have to obtain by a method of least square and a relation to form of E equals to A plus B theta, which fits to these observations. So we go ahead for the same. In some determinations of the value V of carbon dioxide dissolved in a given volume of water at different temperature, the following pairs of values were obtained. So we have your values. This is for theta, this is for V. This is for 0, V equals to 1.80. This is 5, 1.45. This is 10, 1.18. And this is 15, this is 1.00. So that obtained by method of least square or relation of the form V equals to A plus B theta, which fits to these observations. Let us prepare a table for it, so that we'll go ahead finding it out. This is for I, this is for theta, vi square, and theta I and vi. 1, 2, 3, and 4 that we have. So for the same, we go ahead. That is what we have to talk about it. This has been 0, 1.8, 0, then 0. This is 5, 1.45, 25, 7.25, then 1.18, 100, 11.8, 15, 1, 2, 25, 15. Sum of I equals to 1, theta I equals to 30, and I equals to 1 equals to 5.43, and the n I equals to 1, theta I square equals to 350, sigma n I equals to 1, theta I vi equals to 34.05 that we have. Now we'll go ahead for the rest of the values that we have to find it out, and for the continuing this as well. So here we have many of the things related to it, which is being that the equation we get here is sigma n that is being the sigma 4 I equals to 1 is xi equals to 4a plus b sigma 4 I equals to 1 is theta I, which will be equals to further sigma 4 I equals to 1 theta I vi, which is equals to a sigma 4 I equals to 1 theta I plus b 4 I equals to 1 theta I square. Putting the values in the above equation, we get here 5.43 equals to 4a plus 30b and 34.05 equals to 30a plus 350b. Solving these two equations, a equals to 1.758 and b equals to minus 0.0534. Putting a and b, where v equals to a plus b theta, so v equals to 1.758 minus 0.05340. The straight lines fits for this given temperature, and so we go ahead to end up with this, and that we'll discuss in the next coming class. So here we're gonna end up with, but before ending it off, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and maybe you can also enjoy the video as well. Other than CBNST, which is in the computer based numerical and statistical technique, we had done your sociology and software engineering. Even we had done chemistry 11th for class 11th and 12th part 1, and in the same phase that we had done for class 12 is your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, with their conversions, logarithms, anti-logs as well. And after talking about that, yes, we had done ER diagram, we are dealing with English vocabulary, we are dealing with quantitative aptitude. In that we had started with arithmetical ability, where we had done operations on numbers, SCF and LCF of numbers, decimal fraction, simplification, square root and cube root, averages, problems on numbers, problems on ages, such analysis, percentage and profit and loss. That has been the 11th topic that we are dealing here. After completing that, we'll start discussing about the ratio and proportion. In terms of reasoning, we had done your verbal reasoning, that has been the general mental ability and the logic reasoning. In non-verbal reasoning, we had covered up the series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation, analysis, practice question set, and that we had done the reasoning here full. Coming towards computer-based numerical and statistical technique, where in the unit 1 we have completed that. It is in the computer arithmetic errors and rules of equation, where we had completed the floating point arithmetic machine, abscond rounds of error, chopping error, truncation error, associative and distributive law in this floating point arithmetic, inherent error, error propagation, numerical instability in root of equation. We had done second method, Newton-Raphson method, fixed point differentiation method for a simple root and derivatives of the rate of the conversion, static and acceleration of conversion method, modified Newton-Raphson method, and a multiple roots as well, Birch-White method for polynomial, and Weierstrass method for quadratic factor computer algorithm of these methods as well. In unit 2 we have to start with interpolations and curve fitting, where we have to cover up algorithm and the error analysis of Lagrangian, the Newton's divided differences, approximation relationship in the various difference operator, piecewise linear interpolations, cubic spline interpolation, natural spline, Chebyshev's polynomial approximations, and cause economization of the power series. In curve fitting we have to cover up the linear and the non-linear least square approximation, third conditioning at the least square method, Gram-Schmidt's process of orthogonalization, computer algorithm, least square curve fitting. In terms of unit third, which has been the differentiation and integration, we have to cover up that has been the method based on that is interpolations and the finite differences, Richardson extrapolation. In integration we have to cover up the error analysis of trapezoidal and Simpson method, Newton's codes integration method, and Gaussian integration method as well, Gauss-Legrand method, Lobato integration method, Radau integration method, error terms that in pertaining integration method. In unit 4 we have to cover up the solutions of simultaneous linear algebraic equation. We have to cover up the Gauss elimination method, condition that is your the systems and the conditions and number, and successive and relaxive method, rate of the conversions as well. In terms of solutions of ordinary differential equation, we have to cover up the single step method and Runge-Kutta method, as well as the second order, the first or third order, and the fourth order method, multiple step method, and your predictor and the constructor method as well. And statistical technique we have to cover up, that has been the statistical technique hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance test involving that is being the normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. And we are gonna end up with this only. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give us a suggestion down in the comment box. Thank you.